In this experiment, we will determine the amount of iron 2 in the sample using redox titration. This redox titration can be used for many possible IA topics, such as comparing the amount of iron 2 in supplements or tablets, or iron's amount in sample of different leaves or vegetables. Redox titration can also be used for investigations such as determining concentrations of dissolved oxygens (DO) and biological oxygen demand (BOD), where those two indicators can be used for a good sign of pollution in wastewater sample. However, you need to understand some key factors in this redox titration first. Unlike acid and base titrations, where we have to see pH changes using indicators, many redox titrations do not need additional indicators. The changing of oxidation state from the species in the reactions usually shows different colors by itself. Hence, a good research needs to be done first to find out what color for all oxidation states in the reactions will show. For this experiment, 2.5 grams of ammonium iron 2 sulfate crystals are dissolved in water and 30 ml of sulfuric acid into 100 ml volumetric flask. A 10 ml of this solution then titrated with 0.02 molar of potassium permanganate. Theoretically, the titration will follow this chemical equation. See if you can identify which reaction is oxidation, which reaction is reduction, which of the reactant is oxidizing agent, and which of the reactant is reducing agent. The titration will end when all iron have reacted. This means that there is no more iron 2 reaction with permanganate. The observable color at the end will be the color of permanganate will stay purple. This picture shows to you the color of the titrate for all of the 3 trials. Remember, in IA, not only quantitative data, but qualitative data is also important. This table shows to you the raw data collection. 2 accurate data will be used for the calculations. You need to find the average volume of potassium permanganate used using the result of trial 2 and trial 3. Since you know the concentrations of potassium permanganate, which is 0.02 molar, using stoichiometry, you can find the mole of potassium permanganate. Using the ratio from the chemical equations, you can then calculate the mole of iron 2, and after that, the mass of iron 2. The percent of mass of iron 2 from the sample can finally be calculated. Some possible assumptions need to be considered in this titration. For example, we assumed all potassium permanganate react only following the chemical equation that we established. If there are alternate reactions, the actual volume of potassium permanganate needed to react with iron 2 is actually lower than what we get from the titration. Your data volume of potassium permanganate will be higher than what it should be. Finally, the mass of iron 2 also will be higher. What are other assumptions you need to consider? Can you use your calculative data to support your quantitative data interpretation? How do you consider the uncertainties of apparatus when you interpret your data and also draw conclusions?